ahead.
Okay, so this is my West Point Bridge design project. That is definitely weird. That was not how it was when I pressed publish. But anyways, this is my design brief. My client company, the website in which I created is conengineering.com. Is that Mr. Carter? No. Anyways, the target consumer is the purchaser is the U.S. government, and the user is going to be drivers going on the road. I was the lead engineer. The problem statement, there needed to be a bridge built over a trench that was at least, that connects 2 lanes of traffic. Our design statement, my design statement was the bridge needed to connect the 2 lanes of traffic over this trench in a safe, cheap manner that will get the job done. The criteria and constraints was a minimization of cost, must have been at least 24 meters above the high water level, and no more than 32 meters above the high water level to allow room for power lines. They consist of a simple support or an arch support. Each truss may not have more than 50 joints or 120 members for the first bridge. The bridge will have a flat concrete deck with other medium strength concrete or high strength concrete. The materials we could have used to build the trusses were carbon-based steel, high strength and low alloy steel, or quenched and tempered steel. At the cross sections, the trusses could either be made out of solid bars or hollow bars. There are no necessarily restrictions in member size, but it wouldn't function if it was too long. The bridge must be capable of carrying a certain weight, including the trucks that would have been crossing the traffic, and the bridge must comply to the rules of the 1994 Load and Resistance Factor Design, AASHTO Bridge Design Specification. This is definitely wrong. I should have edited this before I knew this was going to be there. But anyways, this is my first bridge. My basis of what I was trying to design off of was a few bridges that I saw over my spring break crossing the Mississippi. There was a lot of trusses above the road, but it wasn't stable enough, so I added the trusses below to sort of balance out the compression and tension forces. And this was my free build bridge. I hit the max design limit of over 200 members for this truss. Yeah, I sort of went the same idea of trusses below and above the actual road, and I didn't excavate anything because that was expensive. So I just added as many members as I could, and it worked. So this is the bridge that I was basing my ideas off of. For the most part, for each members I used somewhere between carbon steel and high strength low alloy steel, because they seem to have been the cheapest, and same with hollow bars. That makes sense that they were cheaper, using less materials to manufacture. But the only times I used solid bars were for the main structural points of where most of the weight was being held. So basically along the bottom of the road and sort of at each end of the bridge. And that's also where I added in the top and bottom trusses. That just made sense to me. The cost calculation report, I used the max amount of members and joints for my constrained bridge, which came to about $432,000. And for my free build bridge, I used 200 members and 59 joints, and it cost about twice as much. And
what was it? 800,000?
800,000 for my free build. And then half as much for my constraint. And this is my bridge is working. That's it.
All right. Next.
Crowd goes by.